Hi guys, today we're going to look at doubling and halving. So we've got our Walt there to solve multiplication problems using doubling and halving. So when we're doing doubling and halving, we generally want to have a number that is an even number within the equation. If we have two odd numbers, you generally can't double and halve. Okay, so looking at, I've got three examples here that we're going to look at. Okay, doubling and halving is a simple strategy. It makes sort of these difficult equations a little bit more simpler. Okay, because what we do to one side of the equation, we have to do something to the other to even it out. Okay, so that's why we double one side and halve the other side. Okay, and we can flip it around. We can halve one side and double the other side. So you just got to figure out which one you want to be able to double and which one you could halve. Okay, so in our first equation, okay, of 13 times 50, we could look at halving the 50. We could halve that to 25 and double 13 to 26. Okay, you couldn't really do it the other way around. You couldn't halve 13 because halving 13 is a prime number, and it's also an odd number. So if we tried to halve 13, we get a 0.5. So that means we can't really do that. We could double one side and then halve the answer. Okay, that would also be another way of doing doubling and halving. Okay, so I think that would be the easiest way to do this one. Okay, so 13 times 100, okay, would seem a lot easier to multiply, and then we just halve the answer. So let's do that one now. Okay, so let's go 13 times 100. Okay, so when we times by 100, most people go, oh, just add on the zeros on the end. No, we don't want to do that. That's not the thinking that we want to push here. What we want to push is there is two place value holders here. Okay, and as we know with our placeholders, when we want to move a place value holder, we times it by 10. So with having two zeros here, I'm actually timesing by 10 and by 10. Okay, so 13, okay, times by 100 is like going 13 times 10 by 10. Okay, so 13 times by 10 means that we add the 0, then we times it by 13 by another 10, and we add another 0. Okay, so that's why when we times by 100, we're moving that decimal point backwards 2 places. Okay, so that's why we get our answer of 1300. So we doubled what we were timesing by, so now we have to halve that answer. Okay, so we're going to divide it by 2 because we times it by 2. So we have to do the reverse of what we just did. Okay, so 1300 divided by 2. Okay, half of 13. Now, this is where, when we had just 13, we worked it into 0.5, but this is 1,300. Okay, so half of 1,000 we know is 500. Half of 300 is 150. Okay, so that would give us an answer of 650. So to our original question, 13 times 50, our actual answer is 650. That's half of what we did of 13 times 100. Okay, hopefully that made sense. So I'll just move that one over the side. So let's look at our next question. Okay, 15 times 12. So which side are we going to double? Which side are we going to halve? If we double 15 to get 30, halve 12 to get 6. That works out quite nicely. That makes that a nice, we've got one digit to be able to times a double digit. And because it's got a 0 on the end, that makes it even better. So we could look at going 6 times 3 times 10. Okay, so 6 times 3 equals 18, times 10 equals 180. Okay, so that was a nice simple one. We could also keep going with our doubling and halving. Okay, so I could halve 6 again to get 3, and I could double 30 again to get 60 if I wanted to. So then I've got 3 times 6 times 10. Okay, it was almost just like the reverse of this one. We've just changed our family facts around, haven't we? Okay, so 3 times 6 equals our 18 times our 10 equals our 180. Okay, it's still the same answer that we had from that one. So that answer is 180. Okay, great. Right, let's have a look at this last example. So 16 times 25. Okay, so 25, if we double 25, that would go to 50. Okay, that would work nicely. And if we halve 16, half of 16, 8 plus 8 equals 16, so half of 16 is 8. We can stop there. We can do 8 times 50. okay, which would be easy. So 8 times 50, 8 times 5 we know is 40, timesing it by a 10 equals 400. So we know that answer already is going to be 400. Okay, but if we didn't know that, if that was too hard, if 8 times 5 was too hard, how else could we do it? Okay, we could double and halve our equation again and go 4 times 100. Okay, we doubled 50, halved that. Okay, 4 times 100, same answer again, 400. Okay, if I still wanted to carry on doubling and halving, I could halve that to 2, double that, 100 to 200. Okay, 200, 2 times 200. Okay, 2 times 2 is our 4 times in 10 times in 10. Okay, to get our 2-digit basically carry over. Okay, and if you wanted to go one more doubling and halving, okay, we could halve 2 to 1, and we could double 2 to 400. So there we go, 1 times 400 equals 400 straight away. Okay, so that's a great example of how doubling and halving works. Okay, a more trickier one, okay, where we had to work it down, but we still were left with a nice single digit to multiply a 2-digit one. And then over this one here we had more of a difficult one where we had 13 times 50, which we worked out we could double 50, but we can't really halve it, so we had to double this side and then at the end halve our answer to get our 650. Okay, so yeah, good luck guys.